Accelerated Algebra. Today we're talking about exponents, exponential functions, sequences. And if you need any extra practice on this, you can always go back and look at your old skill assessments and practice skill assessments. Make sure that you've tried this once already and that you take really good notes as you're going through it. Okay, so first, remember what a negative exponent means. So if we've got x to the negative 2, that means 1 over x squared. We also figured out that 1 over x to the negative 2 simplifies to x squared. So that can help us here. If we've got this fraction raised to the negative 2 power, and then in the numerator I'm going to end up with 4 squared, and in the denominator I'm going to end up with 3 squared and w squared. So that simplifies to be 16 over 9w squared. Letter C. Okay, now notice this negative 1/5 is in the exponent. So I can think of that as 1 over 32 to the 1/5. So we're looking for the 5th root of 32, something that gets multiplied by itself 5 times and makes 32. Well, that has to be 2. So this is going to be 1 over 2, and that is letter B. Okay, this one looks a little more complicated, so I'm going to take it step by step. First, I know that anything to the power of 0 is just 1. I'm going to rewrite x to the 3rd, and then I've got this 2 to the negative 3. The y to the 0 just made 1, so I'm going to leave that out. And then in the denominator here, I've got 2x to the negative 4y. I'm going to simplify one step further, changing up the negative exponents. So I've got x to the 3rd and x to the 4th. And then in the denominator, 2 times 2 to the 3rd times y. So this gives me x to the 7th over 16y. Letter A. So remember, the shortcut when you're doing scientific notation is just how many places you need to move the decimal, because that's the power of 10 that you're really multiplying by. So here I need 1, 2, 3, 4, 5 times to move the decimal. This is a really small number, so it's going to be a negative exponent. 6.74 times 10 to the negative 5. All right, a division here. So we're going to divide these in 2 parts because multiplication and division kind of work all in the same step in the order of operations. So 45 divided by 9 is 5. So 4.5 divided by 9 is going to be 0.5. 10 to the 6th divided by 10 to the negative 9th. That's going to give me 10 to the 15th. Because 6 minus a negative 9. Now this is not scientific notation. So if I make this 10 bigger, I must make this 10 smaller, which is going to give me 10 to the 14th. Letter C. Okay, this equation is obviously going to be exponential growth because we're going up. And how much are we going up by? What would we have to multiply these y values by? Well, we can do some division. We can do 3.6 divided by 3, and that gives us 1.2. So that tells me that each time I'm having to multiply by 1.2. That makes sense. It's bigger than 1 because this is growth, so it should be going up. Here, our starting value is 3. And it's going to be 3 times 1.2 to the power of x, because 1.2 is the thing that's getting multiplied every time. That's got to have the exponent of x. The percent growth, how much more than 100% is it? It's 20% more than 100%, because 1.2, that you can think of as 120%, so that's a 20% growth. This time we just have the equation. So for x equals 0, this part will be 1, so we'll just end up with 5. So that tells me the y-intercept is 5. This is definitely going to be decay because this is less than 1. If it were greater than 1, we'd have growth. So this should say decay. And the percent of decay is 30%. Now why is that? Because 0.7, that's like taking 70% of what we have each time. 70% is 30% less than 100. So 30% decay. So you've got 3 formulas to choose from here. The problem says the town is decreasing in population. So I know this is not going to be growth, and it's not an interest problem. It's going to be a decay problem. Decreasing by 3% each year. In 2010, there were 4,800 people in the town. So we start with 4,800 people. And then every year, how many people do we have left? Well, if we're decreasing by 3%, we have 97% left. And we want to know how many people in 2020, so we're going to ask for 10 years from now. And this says round to the nearest whole number. Don't put any commas on here because you might get marked down if you have a comma and the answer doesn't have a comma in it. Okay, same formula list, but this time it says find the value of 13,500 invested at an interest rate of 4% compounded monthly over 5 years. This is compound interest. So we want to know, if we start with 13,500, how much will we have after 5 years? So the rate is 4%. I have to write that as a decimal. The n is the number of times per year, and this says monthly, so my n is 12. And then the exponent here is 12 times 5, which is 60. So now I'm going to put this in my calculator carefully. I'm not going to round to the very, very end. And again, I would leave off the comma. Looking at some sequences here. So remember, arithmetic sequences have a common difference. Geometric sequences have a common ratio. In this case, I'm subtracting the same thing every time. So that's a common difference. So this is arithmetic. All right, and then the formula. So an arithmetic sequence works just like a linear function, because it really is a linear function. So there are a couple ways you can think of it. You can think of it as the nth term is 0.8 minus 0.3 times n minus 1, because the number of times you have to subtract that 0.3 is n minus 1 times. And then if you go ahead and simplify that, you would end up with 1.1 minus 0.3n. Or you can think of it as, some of you like to sort of back this up to the zero term, and then you realize that zero term, sort of like the y-intercept, is 1.1. Mx plus b form, you write it as 0.3n plus 1.1. So either of these two last ones are fine, and that would be this choice 2. Okay, we've been given an explicit formula for a geometric sequence. I can see because it's multiplying each time here. And we want a recursive formula. So first we need to find the first term, a sub 1. So let's plug in 1. So that's going to give me 8 times negative 2 to the 0, which just gives me 8. So I can immediately rule out D. And then how do we get from one term to the next? Well, if you write them out, like here's a sub 1 is 8, a sub 2 is negative 16. You can figure this out just by plugging in numbers here. And 3 is 32, and so on. To get from one term to the next, you're just multiplying by negative 2. We want something that says take the term before and multiply by negative 2. That's this formula right here, letter C. Sequence 1 was one of the trickier skills that we did. This is skill 22 if you want to look back at your notes and give a little bit more practice there. Awesome, great job.